All right, so today we're going to talk about the amortization of a loan. This is something that really applies mainly to mortgages. This is probably the number one place you're going to see this. It also works with things like car loans and things like that. So basically what amortization is it's the process of gradually paying off a debt with regular payments. And again, mortgage, right? You can see kind of that mortgage idea is kind of tied up in that word. It's got that root word mort, which is death, right? So it's the idea of killing off a loan that you took, okay? So we have a debt, we're making regular payments to pay it off. Okay, loans are paid off in equal installments, but the amount is split between paying the interest versus paying the principal. So when you borrow, say, $100 from the bank, they're going to charge you interest on that. And every month when you make a payment, part of that money that you pay goes towards paying off interest. Part of it goes towards paying off the $100 that you borrowed. Okay, and one thing that I always heard from people was that at the beginning of your loan, you pay more in interest than you do in principal. And then towards the end, you pay more in principal than interest. And I never really understood what people are talking about. So that's one of the things that I want to kind of look at with what's going on here. If you watched the video about annuities, this is the same thing as a present value annuity. It's just that the equation's been reworked a little bit to make it easier to just find the payment. Okay, so here's our equation. R is your periodic payment. P is your principal, the value of the loan, so how much money you borrowed. R is your yearly interest rate, yearly, okay? So that's little r versus big R. N is the number of payments per year. That's usually going to be 12. Usually you have to do monthly payments. And then T is the length of the loan in years. Okay, so it's the number of payments per year, but the length of the loan in years. Okay, so let's look at this example. So in this example, you borrow $50,000, you're going to repay it over 5 years through equal installments made at the end of each year. That is totally unlikely. Nobody's going to let you borrow money and then only repay them once a year. That's not going to be a thing that happens. But for the sake of doing this problem, we're going to look at this table to show how your payments actually work. And if I did something that was a little more realistic, it would make my table really big and just makes it a little bit harder to follow. So I wanted to do something that's a little unrealistic, but the math is easier to understand, okay? So our interest rate is going to be 8% per year, okay, on the unpaid balance. We're going to verify using this table here that the balance is going to be paid off after, sorry, not 5 months, that should say 5 years. Oops. Okay, if this is your amount that's paid every, oops, again, that should say year. So yearly. Okay, I calculated this number using this formula, but for right now, I just want to kind of show you what's going on. Okay, so this is our payment amount. So you can see here, end of period 0, so meaning like before you take the loan, you borrow $50,000. So it's just your outstanding principal. That's how much you owe them when you take the loan. Okay, now you can see that at the end of one period, these repayments, so that's your payment amount that we're making every month. So that's not changing. You pay the same amount every month. Okay, so how is this actually calculated? Well, if our interest rate is 8% a year and we're only making payments every year, then basically if I take my $50,000 and I multiply that by 0.08, 8% is a decimal, that's $4,000. Okay, so that is what this number right here is. So this part, okay, that is how much you owe. So this is the money that you owe. And then you're multiplying that by the 0.08%. Okay, so that's multiplying that by the interest rate that you have. Okay, now it's not always just going to be 8%. If you have something that you're paying off, if you have a yearly percent and you're making monthly payments, you have to mess with this number a little bit, but we're not going to worry about that just yet. Okay, so when you make this payment, this $12,000 payment, $4,000 goes straight to paying your interest. Okay, because for that year, you owe them $4,000 in interest. So of this $12,000, $4,000 pays for your interest, which means that you really only put about $8,000 towards what you actually owe them. Okay, so you're paying a lot of money in interest and you're not paying nearly as much in principal. Well, okay, you are paying more in principal in this particular problem. Okay, but considering that it was $12,000, you're really, a lot of your money is not going towards the principal. Okay, so we pay off our interest. The rest of that payment goes off of this $50,000. Okay, so we got this $50,000. Okay, and then this number right here, this is whatever your balance was, and then we're subtracting the amount of principal that you paid off. So I took whatever this balance was, 50,000, I subtracted this 8,000, that's how much I owe them. Okay? Well, now this same process gets repeated. So now I owe them $41,477.18. I owe them 8% interest. So I'm going to multiply that by my 8%. Okay, well, now this next year I owe them $3,000 in interest. That's where that number came from. Okay, it's rounded, but that's that number, right? The payment amount still stays the same. Okay, but now I pay off that $3,000. Now I've got $9,000 going towards my payment principal. So I owed them $41,000 at the end of the last year. Now I'm paying them $9,000 off of that. Okay, because remember, even though I gave them $12,000, a lot of it goes towards interest. So this is what's coming off of my principal. Great, now I've got the $32,000 that I owe them. Well, 8% of that is this $2,500. Okay, so even though I give them $12,000, $2,000 of it goes towards just interest, and it only knocks my balance down by another, basically $10,000. Okay, get there, do the same thing, 8% interest, how much you actually paying, subtract that from what you owed, right? 8% interest, subtract that, get what you owed. Notice at the end here, you get 1%. Well, that's because we rounded these numbers. Okay, so that's going to happen a lot of times. And when you have a mortgage, you'll see on the statement that they give you, they'll tell you like, this is how much money you owe, but that's not actually the payoff amount. If you want the actual payoff amount, you need to let us know, because when this goes on for a little while, you can go off by just a couple of cents. Not usually much, but a little bit. Okay, so this is what kind of happens. When you go someday, if you ever decide that you want to buy a home, the way that that process works is basically you go in, you go to this bank, you sit there with the banker and you and the person that's selling you the house and maybe a real estate agent or two. And you basically just sit there and you sign an awful lot of papers. You sit at a big table and they hand you a paper and everybody signs it. You pass it around in a circle, everybody signs it. Then the banker explains to you what the next paper is, pass it around to sign it. They explain the next paper, they pass it around to sign it. Okay, so one of the things that they give you is they'll actually give you one of these tables. Okay, so it's called an amortization schedule. They'll give you one of these, only it's going to be way longer. This is just 5 years, assuming one payment per year. And you get a mortgage, a lot of times mortgages, you do 12 payments a year for 30 years, right? So 12 payments a year for 30 years, that's 360 payments. So you're looking at one of these tables, and instead of only having these 6 rows here, you'd have 131 of them, right? So it's a massive, massive table, and they will print it out and they will hand it to you and you'll walk away with it. It was something that I had no idea what it was when I first got my first one. So this is just sort of the math behind what's going on. Okay, so let's look at this guy. And we're going to go through an example and actually fill in what this table looks like. So this one, you get a 4-year, $30,000 auto loan from the bank, and they charge you 3% interest every year. So assuming that you make yearly payments, which again, super unlikely, okay? Most of the time, they're going to ask you for monthly payments. But for this particular problem, I just made it yearly to make our table a little bit smaller. Okay, so we're going to fill in the rest of this table. We're going to figure out how much do we have to pay. Okay, and then I'm going to verify that it works using this table. Okay, so this is that formula that we have at the top of the paper. So to figure out my monthly payment. Okay, so according to this rule, I'm going to start by multiplying the rate times the principal. That's how much I borrowed. So my interest rate is 0.03. And I'm multiplying that by the $30,000 I borrowed. Okay, and then on the bottom, lots of parentheses. N, how many times a year you're making a payment. For this particular problem, we're only paying 1 time a year. So N is 1. Okay, parentheses, then there's 1 minus. Right, so parentheses, 1 minus, then another set of parentheses, and a 1 plus. And then it's R over N. So the rate divided by the number of payments per year. My rate's 0.03. The number of payments per year, again, it's 1 for this one, which is super unlikely for a real life situation, but we're just making our life easier. Okay, and then raised to the negative NT. I tend to forget that negative sign, so make sure you don't, okay? So negative NT, well, the number of payments per year was just 1, and then time was 4 years. So we did this for 4 years. Okay, and now I'm going to throw this into my handy dandy calculator. So 0.03 times 30,000 is 900. All right, and then on the bottom, I'm going to kind of go order of operations here, right? So I'm going to start inside these inner parentheses. I know that's just going to be 0.03, so that'll be 1.03 raised to the -4th power. Okay, and then I'm doing 1 minus that answer. So I'm using second and then this negative button here. See, it says A and S above that, right? So I use that to pull up my previous answer, and I got that. And then I'm supposed to just multiply all that by 1. So this is about 0.11-ish. And then when I divide those two numbers, I don't want to round if at all possible to avoid. So I'm doing 900 divided by, and again, second and that negative sign to just use my previous answer, $8,070.81 rounded. Okay, so that is going to be what my monthly payment is for this loan. Okay, so when I look at the number, okay, I can fill the same number in for my payment made because every month I'm going to make the same payment. It's always going to be this $8,000. Okay, so I owe them $30,000. Okay, and I'm doing 3% interest per year. So $30,000 times that 3% interest, $900. So the first year I pay $900 in interest. So I gave them $8,000. My interest was $900. So the amount that's actually going towards principal is going to be that 8070.81 minus that $900. So this is how much money is actually going towards my principal. Okay, so I owed them $30,000. Now I'm paying them this much of that principal, even though I actually gave them more money than this. This is all that's going towards my principal. I still owe them $22,829.19. Okay, now that's how much I owe them. I have to pay them 3% interest. So times 0.03, I have to pay them this much in interest. So over here in my table, the interest they're charging me, they're charging $684.88. Again, that's rounded. Okay, well, this is my actual payment. So how much is going towards the principal? Well, it's that 8070.81 minus the 684.88. So I'm putting $7,385.93 towards my actual principal. So I owed them this much. So 22,829.19. I'm paying them this much, 7,385.93. So I still owe them $15,443.26. Lovely, but now I have to pay interest again, so I'm going to multiply that by 0.03. And I have to pay them $463.30 in interest. All right, well, my payment amount was at 8070.81, but good chunk of it's going towards interest. So the actual going on my principal is $7,607.51. Okay, and if I owed them that 15, then here's how much I still owe them, $7,835.75, but interest times 0.03. So I have to pay them $235.07 in interest. Okay, so how much is actually going towards my principal? $7,835.74. And when you compare, right, that's almost exactly what I owe them. There's going to be an extra 1 cent left when I subtract those two numbers. But again, that's just that rounding issue, and that happens. Okay, so this guy right here, that's just a rounding issue. It's not anything to worry about. It's something that the bank will take care of for you. Okay, and again, you're not going to have to actually calculate this table. They're going to do it for you. But I want you to see what is going on here, and I want you to understand what they're talking about when they say that you're putting more money towards interest at the beginning of your loan, right? Versus at the end of your loan. You're paying more money here in interest than you are at the end of the loan. Okay. And again, these ones are very unrealistic problems because they're so short. If you look at your actual mortgage statements, when you're looking at something bigger, sometimes you end up where these two numbers here, this will be the bigger number in your payment. That you'll pay $8,000 a month for your mortgage, but like 7,000 of it is going towards interest. It's ridiculous. So it can be just really, really crazy to see what happens. Okay. So this is kind of the idea of what amortization is. Now, I'm not going to ask you to make these big tables all the time. I just want you to kind of see what they look like. So let's talk about why do you care? Okay, so you kind of understand what's going on with these tables and how this percentage thing with the interest and all this stuff. Okay, so what's actually happening here? What's the part that I'm going to actually like care about? Okay, so let's look at what's going on. All right, so let's look at this example. So this family, they borrow $120,000 to buy a house. The bank charges interest rate at 4% per year. Depending on the year, interest rates usually fluctuate. They're usually around 3 to 4%. Sometimes you can get a little lower than 3, but that's pretty typical. Okay, so you pay 4% for this particular loan. Interest calculations are made at the end of each month. So this is going to be more realistic because we're talking monthly payments now. They've agreed to repay it in equal monthly payments over 30 years. So question one, how much do they have to pay each month for it to actually work out? So to figure out my monthly payment, right, I'm just using this formula that we were looking at. So it's the rate of interest, which is 0.04, times how much you borrow, 120,000. And then in the bottom, N is how many payments you're making per year. Well, they're paying at the end of each month. So N is 12. Okay, so they're paying it each month, so N is 12. Okay, and then it's parentheses, 1 minus, another set of parentheses, 1 plus, the interest rate divided by that same N, the same number of payments, and then it's raised to the negative N times T, the amount of time. Okay, well, they borrowed this over 30 years, so T is 30. So that's 30 years. Okay, and I'm going to take this, I'm going to throw this all into my calculator. So 0.04 times 120,000. Okay, so that's $4,800. Okay, and then a denominator, I'm starting the innermost set of parentheses. So I'm going to do 0.04 divided by 12, add the 1 to it, raise it to the negative 12 times 30. You have to put parentheses around that. If you don't put parentheses, it'll raise it to the negative 12th and then take that answer and multiply it by 30. Okay, we want it to multiply first, so we need parentheses. Okay, so we got that. So I did this part and I raised it to this. Now I have to do 1 minus that answer. So 1 minus that answer. And then I'm multiplying it by 12. So it's this 8.38-ish number. And then I'm doing 4,800 divided by that answer. So that's $572.90. Okay, so they borrowed $120,000. Over the course of 30 years, they're making this much in monthly payments. Okay, so we calculated their monthly payment. Now, question two, assuming that they never refinance and they own the home for the entire period of the loan, how much do they actually end up paying for their house? Okay, so refinancing is basically like in the future, maybe the Blakeleys will be looking around and they'll be like, oh, well, the interest rates have dropped to only 2% a year. So maybe I should refinance my house, which is basically like saying, I'm going to take a new loan off to pay off the original loan at a lower interest rate. Okay. And then owning it for the entire length of the loan, people move. So if you decide to move partway through, then, you know, you obviously wouldn't have paid off your whole loan because you'd pay off the rest of the house, you know? So assuming that doesn't happen. So assuming that they actually stick around the whole time, how much do they actually end up paying? Well, think about it. So they're making 12 payments a year for 30 years. So they're taking this $572.90, they're paying that 12 times a year for 30 years, right? So this much money, 12 times a year for 30 years. So what does that actually work out to if I calculate that, right? So $572.90 times 12 times a year times 30 years, they actually end up paying $206,000, 244, right? That number. So look at this. They borrowed $120,000 and look how much they actually end up paying over the course of 30 years, right? So even though your house may only cost you $120,000, that's not what you actually pay for it, okay? Assuming the same thing, they actually stick it out for the whole time, how much do they pay in interest? Well, they're paying this $206,244, right? But the actual cost of the house is only $120,000. So how much do they actually end up paying in interest? Well, this is everything else that they paid, right? So on top of oops, I missed a comma. Hang on. Not a comma. I missed a zero. There we go. That's enough zeros. That's a little more realistic. So $86,244. My bad. Okay, so they end up paying on this loan $86,000 just in interest. Okay, this is how mortgages work. This is not unusual. This is not that they're being taken advantage of. This is how it goes. This is what happens with mortgages, and that's just how the industry works. Okay, so whenever you buy a house, right, you're going to pay a whole lot of money in interest. So whatever the sticker price is, and this doesn't just go for houses, it goes for a car loan, okay, anything that you're going to borrow a loan for, whatever the sticker price is and what you actually end up paying are vastly different numbers.